Transformation of functions. This topic is essential in having a flexible view of functions and their behavior. And recall that we have a set of functions that you were supposed to recall, what we refer to as a list of basic functions. What we're going to do now is do some composition. Of those basic functions. And I'm going to turn on my lamp here. It's kind of dark. Okay. Now let us say that f of x represents our basic function. And in reality, f of x can be any function. Okay. The functions m of x and e of x are two linear functions. So, okay, remember, linear functions of the form. I'm going to write this very basic, but L of x, and then we have the slope of the line times your variable times, sorry, not times, plus y-intercept. And more precisely, the y component of the y-intercept. Or symbolically, the way more and more used to seeing it as mx plus b, where again, b is the y-intercept in that form. Great. Now we're going to see that what occurs when this function, this f of x, which could be anything, when we compose it in the following manner. Let's say that m is a function, a linear function, so we're going to do this. Take this whatever function is and drop it inside, again, a linear function. Okay, so again, this is linear. Or we could do this. Let me drop it the other way. Like so. And again, this e function is again linear. Or we could do both. We can do this. It's m of f of e. So we're composing twice. Again, the linear function inside this general function, and then outside we have a linear function. Okay, so these are all, again, linear functions. Another way of looking at this is follows. Let a, b, c, and d all be constant real numbers. Then what happens when we do the following? Again, we can look at it this way, f, and then drop inside of it a linear function. That is, we compose f of x with a linear equation. And then again, the linear equation being ax plus b. Or the other way around, we can have this, where now the variable is the entire function f of x. So now again, this represents your variable for the linear. So that is essentially what we're doing. Okay. So now let's look at a quick little example. You may have already done this in the past when you studied quadratics in the vertex form of a quadratic. So a quadratic is of the form, again, y equals ax squared plus bx plus c, which in its most simplest form is this, y equals ax squared, and you may recognize it as being one of the basic functions, where again, a also becomes a 1, and b becomes a 0, and c becomes a 0. So this is the simplest way you can write a quadratic. When you factor a quadratic into a particular form called perfect squares, you get the following scenario. And then this is what I'm hoping you may have been exposed to in the past, where all of a sudden, when you factor, we're not going to do this, factor, that is, you get this equation where hk is the vertex of the quadratic function. Okay, so these two constants, h and k, turn out to be the position of the vertex of a quadratic, and that's the reason to get it into this format. And a is the constant from the form, again, ax squared plus bx, so that's the same a you see right there. And if you look closely, we are composing with a linear equation. So again, how does that work? Well, look, you have your basic function right here. And now, if I do this, there is the slope. And this is the, y-intercept. And again, inside of this is the quadratic function, the any f of x, right? So that's what we said we were going to drop in here, any f of x, and what we're dropping in is this function right here. But then inside of this, we're also composing. So when you break this down, now we're saying, look, inside the quadratic, we're doing this. So we're now dropping this inside the function. In this case, when you see it this way, the a happens to be a 1. So I want to do this again where a is equal to a 1. Okay, but this is essentially what we're going to do. And again, you've sort of been exposed to this. So again, we're not going to do that, meaning factor, to get it into that form. Instead, we're going to start with y equals x squared and see that what the actions of composing do to the basic function. So the goals and benefits are this. Understand how a function behaves when composed with a linear equation. Recognize when a function is a result of composition with a linear equation. Given a function in graph form, find the resulting transformation. Given a transform known basic function in a graph form, write down the equation of that graph. And there's a couple more other things, but that's definitely the core of what we're going to try and do.